All right, everyone. Welcome back to the land of Chem. I am your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again. All right, everyone, welcome back. This is the moment you have all been waiting for, episode 36, the chemical analysis of the red pyramid staining. And I must admit, I am more excited about this video than I have been about any of the previous episodes. So in today's episode, I am finally going to reveal the results of the chemical analysis of the samples of the black staining taken from inside of the red pyramid by the Isida Project circa 2010. So after translating the Russian article about the hypothetical CO2 furnace inside of the bent pyramid, I discovered that the Isida Project had taken samples from inside of the red pyramid, and I immediately contacted them to see if we could exchange research. So the Isida Project and I actually have some mutual connections in common in Egypt, so I dropped some names in my initial email, and after several weeks of very anxious anticipation, I finally heard back from them and we began to exchange research. So I've been following the Isida Project since around 2012, and it has been a very cool experience for me to finally develop a working relationship with this team, which I hold in the highest esteem. This is one of the most prolific underground research groups that has been studying the Egyptian pyramids, and I highly recommend checking out their website and YouTube channels, and I'll put some links in the video description below. This is where my story of my interest in the proposed function of the Egyptian pyramids began, and their research was literally the foundation of my investigation until I had a chance to go to Egypt to see the pyramids in person during my 2017 research expedition. So when I received this PDF, I was completely perplexed by the results of this chemical analysis, and it was somewhat contradictory to what I had anticipated. However, after several days of research and many headaches, I finally realized what this material was doing inside of the red pyramid and what had caused that black staining to form. So ladies and gentlemen, in today's episode, I'm going to be presenting the entire PDF that was sent to me by the Isida Project, along with some exclusive photos and videos from inside of the red pyramid from my 2017 research expedition, and a comprehensive of this chemical analysis. So ladies and gentlemen, without further ado, it is with the greatest pleasure that I can finally present to you the chemical analysis of the black staining taken from inside of the red pyramid by the Isida Project, and in my opinion, conclusive evidence of the high temperature, high pressure chemical reactions that were once occurring inside of that structure. So ladies and gentlemen, without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. So in the first few images, I'm going to give you a brief tour through the red pyramid so that we can assess the black staining found in those chambers. So this first couple of pictures are from inside of the first chamber of the red pyramid, otherwise known as the primary steam reformer. Now, as we move through the structure, you will notice that there is significantly more staining on the southern walls of the first two chambers and the western wall of the third and final synthesis chamber. This is an indication of the direction of the reaction, moving south from chamber 1 into chamber 2, and then being compressed toward the western wall of the final synthesis chamber. We'll be discussing this later on in today's episode. So in this image, this is showing the southern wall of that same chamber, the primary steam reformer, the first chamber inside of the red pyramid. And you can see here in this image the significant difference in the concentration of the black staining found on this southern wall compared to the northern wall of the same chamber. And this next image, this is from the upper vault of the primary steam reformer, the first chamber inside of the red pyramid. And I wanted to show this image so you can see that there are no holes inside of this chamber. This is incorrectly depicted on almost every single diagram of the red pyramid, indicating that there are holes inside of this first chamber. I also thought that these holes existed and were perhaps mounting recesses to hold beds of mesh catalyst material that was stretched across this upper vault. However, after my first year of on-site investigation inside of this structure, I very quickly realized that there are no holes inside of this first chamber, and I discarded that idea about the catalyst mesh beds that were stretched across these upper vaults. So after studying those holes for several years, I have come to the conclusion that they are not a part of the original structure. Also, in our modern process for the manufacture of ammonia, catalyst is used in the first and third chambers of the reaction, which is contradictory to what we find inside of the red pyramid. There are no holes in the first or final synthesis chamber of this structure. However, there is more to come on the catalyst discussion in a later video. So next up, ladies and gentlemen, this is a picture of the northern wall of the second chamber and the upper vault of the second chamber. Now, this is the area from which those samples were taken, because as you climb the staircase leading up to the final synthesis chamber, this is the easiest area to access the upper vault and that black staining material. And you can see here from these old pictures from inside of the red pyramid, a modern staircase now completely covers up this southern wall of the second chamber. However, you can very clearly see that there is significantly more staining on the southern wall of this chamber as compared to the northern wall of the same chamber. All right, so next up, you're going to see some close-up images found inside of the second chamber and the black drip staining that is emanating from these holes. So these pictures were taken from my 2017 research expedition inside of the Red Pyramid, my first opportunity to go inside of this structure, and you can clearly see the black staining that is emanating from these holes. And these are a few images of the holes that are found in the upper vault of the second chamber inside of the Red Pyramid. Again, these are the same holes that are depicted incorrectly in all of the diagrams of the Red Pyramid, showing that these are in the first chamber. That is not the case, ladies and gentlemen. These holes are only found inside of the second chamber. And when I took this picture, I was standing at the top of the staircase leading into the final synthesis chamber. And again, you can see that it is very easy to access the black staining and take samples from this area of the structure. And here is another image of the upper vault of the second Red Pyramid, and you can very clearly see the dark black nebulous staining that is completely covering the upper vault of this chamber. And here's another exceptional image taken from the top of the staircase looking down into the secondary air reformer. And just note, ladies and gentlemen, that this black nebulous staining starts precisely at the third tier in the upper vault. We'll be discussing that later in today's video. And these next couple of images are just from the final synthesis chamber inside of the Red Pyramid. And this chamber is where the intense smell of ammonia emanates. This is where the smell is coming from, which is another indication that the ammonia smell inside of this structure has absolutely nothing to do with the presence of bats. And here, ladies and gentlemen, are a few short, exclusive clips from inside of the Red Pyramid, which I completely forgot I had taken, and I haven't released yet here on this channel. And you'll notice that from this video, from back in 2017, Yusuf and I were talking about the ancient alchemy inside of this structure and how a chemical analysis of this black material should be performed. And I never could have anticipated that 5 years later, we would be here today about to reveal the truth to the world. So ladies and gentlemen, I hope you enjoy.
I don't think so. Why? Because the line looks too straight for the bats to be standing in a row like that. You see that?
Will you shine the light on the wall here again? It smells like ammonia.
It smells like ammonia. And this smell is coming from that chamber up there. Should be analyzed to understand what is the alchemy of it. What is the...
All right, everyone, brand new merch drop is now available at thelandofchem.com. There are a ton of awesome new colors with the OG second degree logo designed by yours truly. And this is a 45, 45, 90-degree triangle representing the Red Pyramid of Dashur, featuring molecular ammonia inside of the structure. I also have some brand new logo designs finally available on the t-shirt website. And I made my website navigation a little bit easier to find the t-shirt shop. All you have to do is click the menu drop down, go to shop merch, and that'll take you directly to the t-shirt website. This new logo is the 5th degree within the Land of Chem book, and this is a raw image of the Central Pyramid of Giza featuring the alchemical symbol for hydrochloric acid. And this was produced as a collaboration with a friend and supporter of the Land of Chem channel by the name of Adam. Adam, thank you so much for helping me bring my vision for this new logo to life. You did an absolutely spectacular job. These things look amazing, dude. Thank you so much. And last but not least, a Land of Chem exclusive, the new 5th degree logo in the exclusive violet print. I absolutely love these things. They are now available at www.thelandofchem.com. And of course, limited first edition print copies. These are absolutely gorgeous, and I'm so proud of how these little books turned out. Are also now available on the website, www.thelandofchem.com. So if you want to help support the channel, go to the website, grab a new t-shirt, pick up a copy of the book. All of these orders mean so much to me. So thank you all so much in advance. So at this point, ladies and gentlemen, I can only hope that your anticipation is just boiling over. So let's jump right in to this PDF that was sent to me by the Isida Project. And shout out to the whole team at the Isida Project for putting together this absolutely exceptional research. Thank you so much for sharing this with me and letting me put this out to the public here on the Land of Chem YouTube channel. So, ladies and gentlemen, let's get right to it. So these are just a couple of pictures of the Red Pyramid of Dashur and a review of the internal components of the structure. So of course we have the northern pump shaft, your primary steam reformer, your secondary air reformer, and your final synthesis chamber. And as I've already explained previously in this episode, there are no holes found in the primary steam reformer, nor are there any holes found inside the final synthesis chamber. So this is an incorrect depiction that is found on almost every single diagram of the Red Pyramid. And next up, this is an image of the staining found inside of the portcullis housing inside of the bent pyramid. So this is the stone valve right here, and this is the interior housing of that moving sliding stone door system. And you can see here in this image that there is some of this black drip staining, very similar to what you find inside of the Red Pyramid of Dashur. And these are a couple of pictures from my either 2020 or 2021 research expedition, just showing that exact same area inside of the bent pyramid and the black staining that is emanating from the limestone blocks of this portion of the chamber. And I will note, ladies and gentlemen, that when you stick your head inside of this little portcullis system, there is absolutely no smell whatsoever of ammonia. So these stains, ladies and gentlemen, once again, have nothing to do with bats. And here, ladies and gentlemen, in this image, this was taken from inside of the bent pyramid's satellite pyramid during either my 2020 or 2021 research expeditions. And you can see the black accumulated material that is developing here on the lower tiers of this vault system. And there is a definite pattern to the accumulation of this material. And upon entering this structure for my first time, I was very perplexed at this pattern, and I did not have an explanation of how or why bats could produce this pattern. Well, now that I know exactly what this material is, I also have an explanation for the formation of this pattern. And here are just a couple of images from inside of the Red Pyramid, this being the first chamber, the primary steam reformer. This next one being from the upper vault of the secondary chamber, the secondary air reformer. This is a picture of some of the very linear staining that is found inside of these chambers, and I discussed this in my previous episode, my 2021 research expedition recap from inside of the Red Pyramid. And here is an image taken from the final synthesis chamber of the Red Pyramid. And next up, ladies and gentlemen, the Isida Project begins with their analysis and negation of the bat urination hypothesis. So you can see here, they are taking measurements of the distance between the joint in the stone and the beginning of the linear staining that we find inside of these chambers. And you will notice that there is a distance of 5 centimeters between the joint and the beginning of the staining. Now, I had also proposed a similar hypothesis and explanation for this red linear drip staining in my previous episode, my 2021 research expedition recap covering the Red Pyramid. And Yusuf and I had discussed and proposed that it was perhaps an explanation that the bats were attaching themselves to the walls here, hanging upside down, and then urinating on the walls, creating this red linear drip staining. However, after a thorough analysis of that proposed hypothesis, I found it to be completely wrong. If a bat was hanging upside down from this crack, it wouldn't be urinating all over itself while it hung up against the wall. Nor would these bats have a coordinated urination strategy, all agreeing to hang here and pee in a line up against the wall. That is absolutely incorrect. Not to mention that in all the other structures in Egypt where we find bats, there is absolutely none of this red drip staining. So, moving right along to the Isida Project's mutual negation of the bat urination hypothesis. You can see here, this is an image of a bat. And they are proposing that exact same explanation, that perhaps the bats were hanging approximately 5 centimeters from the tier of the vault, peeing up against the wall, right? Sounds like a reasonable enough explanation. However, and here are a couple of images showing that linear red drip staining that I've been discussing in the previous slides, and this was taken from inside of the second chamber of the Red Pyramid. Now, as I was saying, the Isida Project was making the exact same proposition, that perhaps the bats were hanging here up against this little crack and peeing against the walls. However, just take a look at this image from inside of Mastaba 17 from my 2021 research expedition to Egypt. You can see congregating inside of this structure, and you will notice that none of them have agreed to line up, hanging up on a crack in the wall to form a linear pattern. Not one single bat. Also, you will note that there is not one red drip stain inside of this chamber. Now, there is plenty of bat feces covering the floor inside this chamber, but there is absolutely zero smell of ammonia and no staining whatsoever found inside the structures that actually have bats. Next up, this is an image from my 2021 research expedition from inside of the primary reaction chamber inside of the bent pyramid. We know and have video evidence of a massive colony of bats that once inhabited this structure. And you will also note that there is no linear drip staining inside of this structure whatsoever. You do have some of that black material emanating from the stone itself inside of this chamber. But again, we know that there was a huge colony of bats inside of this structure, zero linear red drip staining, and zero smell of ammonia. And here on this slide, the Isida Project provides another exceptional piece of evidence that completely negates this bat urination hypothesis. Just look here. At the junction of the last two blocks in the ceiling, you will notice that there is that black material emanating from this junction in the stone. If this staining was produced by bat urine, how exactly are they producing this material coming from the junction in the stone? This completely negates the bat urination hypothesis. These stains have absolutely nothing to do with bats. And next up in the PDF, the Isida Project discusses briefly the tightness of the junction between the blocks inside of these chambers. Ladies and gentlemen, the chambers inside of the Egyptian pyramids are hermetically sealed. They were not only watertight, but they were also airtight. All you have to do is spend a few minutes inside of these structures and you will come to the exact same conclusion. And here's just a couple of more images showing the tightness of these wall junctions. And you can see here in this close-up image, it almost looks as if these two stones have been fused together. Again, these are hermetically sealed chambers, not only water, but also airtight. And here is another image of that hole found inside of the second chamber and the significant amount of that black material that is coming from inside of this hole. And they took pictures approximately 8 months apart, and you can see that that material is still extruding from the stone today, a very, very unusual feature of this black material. All right, everyone, the moment we have all been waiting for, the results of the chemical analysis of this black staining material taken from inside of the Red Pyramid. And the instrument that was used to perform this analysis is something known as an analytical electron microscope. So this instrument can not only take high quality, high resolution images of the sample material, it can also simultaneously perform a chemical analysis of those samples. So here are a few high-resolution images of the material taken from those samples performed in this SEM discovery. And you can see in this second picture that there is a crystalline structure to some of this material. Very, very interesting, particularly when we get to the breakdown of the chemical composition. So now, before we jump into the results of this chemical analysis, let's review the chemical composition of bat urine and bat guano so that we can compare this to the samples that were taken from inside of the red pyramid. So the composition of bat guano is mostly nitrogen. This nitrogen content is approximately 80% uric acid. You're also going to find some proteins, some ammonia, and some nitrates. So uric acid's chemical composition is carbon, hydrogen, nitrogen, and oxygen. Ammonia, we know, is nitrogen and hydrogen. So if these samples are of biological origin as related to bat urine or bat guano, we would expect to find significantly elevated concentrations of nitrogen, hydrogen, carbon, and oxygen. Also found inside of bat guano and urine are in large concentrations sulfur and phosphorus. So we're going to expect to see nitrogen, hydrogen, carbon, oxygen, sulfur, and phosphorus in large concentrations if this material is related to bat urine or bat guano. So just keep those in mind as we proceed with this chemical analysis. So here we go with the results of this analytical scanning electron microscopy discovery. And on this first slide, they are analyzing this small portion of the sample here, which is highlighted by this pink square. And you can see that in this portion of the sample, it contains almost 50% oxygen. You have a very small amount of sodium, small amount of phosphorus, small amount of sulfur, a little bit of chlorine, and a somewhat elevated amount of potassium. So there's nothing particularly unusual about this sample. However, it does not contain any carbon whatsoever, which is certainly what we'd expect from a biological sample produced from bat urine or bat guano. You will also notice that there is no nitrogen or hydrogen whatsoever in this sample, and we would also expect to find that if those nitrogen and hydrogen elements were bound into nitrate compounds that are associated with bat guano. Absolutely none of that found whatsoever in this sample. However, nothing particularly unusual about this sample either. So moving on to the next one. And next up, we have this portion of the analytical SEM discovery highlighted in this pink box here. And you can see the elemental breakdown of this particular sample. And you will find that there is some carbon, some oxygen, some sodium, magnesium, silicon, phosphorus, sulfur, chlorine, potassium, and calcium. So, ladies and gentlemen, there's nothing particularly unusual about this sample either. Everything that we find here could certainly be explained by biological origin, but it could also be explained simply by the fact that limestone is composed of calcium carbonate. So you would certainly expect to find calcium and oxygen in those samples. The presence of sodium, magnesium, and silicon are certainly not unusual for a natural sample of stone. The levels of phosphorus and sulfur, however, in this sample are very, very low, exactly what we saw in the first sample, not compatible whatsoever with biological material as related to bat guano or bat urine. So again, nothing particularly unusual about this sample either, but it's certainly not indicative of something that was caused by bats. So let's move on to the next sample. And next up, they're doing this again, analytical microscopy discovery of this portion of the sample here. Again, the chemical composition is getting a little bit more unusual. So we have carbon, oxygen, sodium, magnesium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, zinc, and barium. So barium is a bit of an unusual compound, not something we would necessarily expect to find in a biological sample coming from bat urine or bat guano, but again, nothing particularly unusual about this sample either. So here, ladies and gentlemen, is where these samples start to get a little bit more unusual. So now they're analyzing this particular component of the sample here, and you can see here on the right, the elemental composition of this sample. So we have some oxygen, we have significantly more sodium than found in any of the other samples, a tiny amount of phosphorus, almost 50% of this sample is chlorine. Again, something that is completely contradictory to what we would expect to find from a biological sample as related to bat urine or bat guano. There is a tiny amount of potassium, a very, very small amount of calcium. This is incredibly unusual considering that we would expect these chambers to be composed of calcium carbonate and would expect to find significant levels of either carbon or calcium in these samples. We find almost none whatsoever. So like I mentioned before, this is where the story starts to get a little bit more unusual, is the concentration of molybdenum found in this sample. So getting a little bit more mysterious, moving on to the next one. All right, so here we go. The next sample taken from this electron microscopy discovery, analyzing this portion of the sample here. So we will see there's some carbon actually found in this sample, a little bit of oxygen, a very, very small amount of sulfur and phosphorus. Again, if this was bat guano or bat urine, we would certainly expect to see much higher concentrations of sulfur and phosphorus. Very small amount of chlorine, a little bit of potassium, very small amount of calcium. And look at what we have here, ladies and gentlemen. This sample is almost 50% copper. Again, things are getting a little bit more interesting and more indicative of something that has absolutely nothing to do with bat urine or bat guano. On to the next one. All right, so here in this portion of the sample here, we have the elemental breakdown containing oxygen, phosphorus, sulfur, potassium, and calcium, all in very, very small concentrations. The majority of this portion of the sample is almost 90% by weight made of zinc metal. Ladies and gentlemen, we are moving further and further away from anything that could be possibly explained by bat urine or bat guano. Moving on to the next one. So here in this sample, we are looking at this portion here, which contains carbon, oxygen, sodium, magnesium, silicon, phosphorus, chlorine, sulfur, potassium, and calcium, all in very, very small concentrations. However, I'm sure you will notice that almost 60% by weight of this sample is iron metal. So in the previous 3 slides, we showed that these samples contain significantly elevated concentrations of zinc, copper, and iron metal. Things are getting more and more interesting. So here in this sample is where we can completely begin to negate, without any question whatsoever, any argument that proposes that the material from these samples come from bats. So let's just take a look at the chemical composition of this sample here. So we got some carbon, oxygen, sodium, phosphorus, sulfur, potassium, and calcium. Very, very similar to the previous samples. However, you will see that in this sample, almost 50% by weight is, drumroll, antimony, ladies and gentlemen. Antimony, one of the first metals that was being extracted and studied by these ancient alchemists. So in the previous 3 samples, we've seen that this black material contains significant concentrations of copper, zinc, iron, and now antimony. 4 metals that were being extensively extracted and studied by these ancient alchemists. And the presence of antimony, an almost 50% by weight concentration in this sample, completely refutes any explanation whatsoever that claims that this material is produced by bats. And ladies and gentlemen, we haven't even gotten to the most interesting part of this video yet. So in the final sample of the analytical SEM discovery portion of this PDF, we see the elemental composition listed here. So we have some carbon, some oxygen, some sodium, some phosphorus, some sulfur, some chlorine, some potassium, and some calcium. Nothing unusual whatsoever there, could be explained by biological origin. However, just take a look at this here, ladies and gentlemen, and you may not even recognize what this TH elemental symbol represents. And it is almost 40% by weight of this particular portion of the sample. Ladies and gentlemen, some of this material contains 40% of thorium. That's right, ladies and gentlemen, you heard me correctly, thorium. So before we move on to the full breakdown of the chemical analysis that was performed by the Isida Project, let's just briefly review again the chemical composition of bat urine and bat guano. Again, the most conventional explanations from this bat staining is either carbon and soot from torches used inside of the structure, or of course the explanation that all of this black staining is caused by the bats. So if it was caused by the bats, or if it was caused by soot from torches, we would expect to find almost complete concentrations of carbon found in these samples. We find almost no carbon whatsoever. We would also expect to find nitrogen and hydrogen compounds. We don't find those whatsoever in any of these samples, nor do we find the elevated concentrations of sulfur and phosphorus that would be expected to be found in these biological samples if they were produced by bat urine or bat guano. But, ladies and gentlemen, we are finding copper, zinc, iron, antimony, thorium, all elements, the presence of which cannot be explained by bats. So last but not least, ladies and gentlemen, here is the full chemical analysis breakdown, the microelement composition of the material taken from inside of the red pyramid. And I'm going to read you the concentration of the elements found in these samples, starting with the elements found with less than 1% concentration. So starting with praseodymium, neodymium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thallium, ytterbium, lucium, hafnium, thorium, uranium, beryllium, scandium, gallium, yttrium, niobium, molybdenum, and cesium. Now, ladies and gentlemen, I am certainly not proposing that there were nuclear reactions occurring inside of the red pyramid of limestone, particularly in deep sea deposits of limestone. However, these are under no circumstances found in bat guano. These stains have absolutely nothing to do with bats. This is literally case closed, and I haven't even gotten to the main component of the sample yet. So as I've mentioned before, the stones utilized in the construction of the Egyptian pyramids were quarried from very specific locations, and the red pyramid itself is made of a completely different type of limestone than is found in any of the pyramids in Egypt. Everything about these structures was intentional. There was nothing superficial whatsoever about these constructions. Everything was done for a very specific reason, and perhaps these quarry sites were also selected very, very intentionally due to the chemical composition of the limestone at those sites. More to come on that in a later video. So next up, I'm going to read you the list of the elements with concentrations from 1 to 10 grams per ton in this sample. So we're looking at cerium, lead, chromium, nickel, rubidium, and zirconium. So now, at this point, ladies and gentlemen, does anyone still think that we are talking about biological material that is produced by bats living inside this structure? Anyone? Anyone? No? Good. We're all on the same page. This staining has absolutely nothing to do with bat urine or bat guano. Also remember that these samples contain elevated levels of antimony and iron that were mentioned in the previous slides, and I have an explanation for the presence of all of these elements inside of these structures. That's going to be coming up in a later video, as these are not the primary material that make up the stains. And next up on the chemical composition breakdown, the elements from 10 to 50 grams per ton in this sample. And we have three, which are barium, zinc, and copper. So ladies and gentlemen, last but not least, the black staining from inside of the red pyramid is mostly made of strontium. That's right, ladies and gentlemen, you heard me correctly, strontium. Now some of you may be asking yourself, what the hell is strontium and what is it doing inside of the chambers of the red pyramid? So strontium is an element that has a very similar atomic composition to that of calcium, and we will see that strontium is found in sedimentary rocks. Elemental strontium, in fact, has a strong affinity for limestone. The strontium can actually substitute the calcium in the calcium carbonate lattice. Strontium is also found in the shells of some deep sea creatures. So ladies and gentlemen, we know from our previous episodes discussing the geology of the Egyptian pyramids that limestone is made of calcium carbonate and shells. So the shells inside of that limestone contain strontium. And in some cases, the calcium from that calcium carbonate can actually be substituted with strontium, making the limestone not calcium carbonate, but rather strontium carbonate. So the presence of strontium in these samples is coming directly from the limestone itself. So, as was described by the Russian research team that developed that CO2 furnace hypothesis, they had also proposed that this black material was being extruded directly from the limestone as a direct result of the static pressure from the weight of the body of the stones on top of the chambers. However, I would argue that it is not a result of static pressure that causes these extrusions, but rather dynamic pressure inside of these chambers. According to my theory, there would have been fluctuations between high pressure and low pressure systems inside of these chambers. As the pressure dropped inside of the system, the extrusions began to form. So one question, why is this material only found in the upper vault? This is the only area of the chambers that experienced the dynamic pressure changes. If it was a static pressure situation, we would expect to find those black streaks developing all over every single stone in the chamber, the upper vault, the lower sections, the connecting shafts, etc. But that is not what we find inside of those structures. The black streaks and staining are only found inside of the upper vault. So the next question that arises is, why is there greater concentration of staining on the southern wall of the first two chambers and the western wall of the final synthesis chamber? And as I mentioned before, this is an indication of the direction of the reaction. So the pressure inside of this system was forcing the reaction south through the structure from your primary steam reformer into the secondary air reformer, and then finally into the final synthesis chamber where that ammonia solution was being produced. So as the dynamic pressure changes inside of this structure forced the reaction through the structure, the areas that experienced the most significant changes in pressure, i.e. the southern walls and the western walls, are the areas where we see the greatest amount of those extrusions. So the next question that inevitably arises is, why is there no nitrogen or hydrogen inside of these samples if ammonia was being produced inside of this structure? Well, ladies and gentlemen, that's a fairly simple explanation. Nitrogen, hydrogen, and ammonia are all gaseous molecules. The samples taken from inside of the red pyramid are solid samples. There wouldn't be any gaseous nitrogen, hydrogen, or ammonia found in these samples unless the nitrogen or hydrogen had been bound into a solid compound molecule, i.e. the nitrates that we would expect to find in bat guano. However, we find absolutely zero of those nitrate compounds, and this again is evidence that the black staining inside of these chambers has absolutely nothing whatsoever to do with bats. So now, ladies and gentlemen, it is with the absolute greatest pleasure that we can now finally and conclusively prove that the staining inside of the red pyramid is not caused by bats. It is a direct result of extrusions of strontium coming out of the stone created by the dynamic pressure fluctuations that were occurring during the chemical reactions that once occurred inside of this miraculous ancient structure. All right, everyone, that is it for today's video. This was episode 36, the chemical analysis of the red pyramid staining. I really hope you enjoyed today's video. And ladies and gentlemen, I am absolutely ecstatic that we will never again have to discuss the bats here on this channel. Also, huge thank you to the Isida Project for conducting this research and allowing me to present it here on the Land of Chem YouTube channel. So that being said, if you have Instagram, follow me on the gram at the Land of Chem. If you're watching this video and you like the material, please subscribe to the Land of Chem here on YouTube. If you like the video, leave it a like. If you have any questions, comments, feedback, leave that in the comment section below. I genuinely enjoy interacting with everybody in the comment section, and thank you all so much for your continued support of this project. I think that is it for today's video, so I will see you next time.